In lesson 2, we take what we learned in lesson 1 and start using it in our applications and why these angle relationships are so important. Well, parallel lines allow us to use our different types of angles to determine things about the values of them. This is important here. Corresponding angles, alternate interior, alternate exterior, they're all congruent to each other, which means they are all the same. So that's going to be important. If one is worth 50, the other ones that correlate with it or corresponding or alternate interior exterior, they're also going to be 50. They're going to be worth the same amount. Our consecutive angles, the same side ones, they are always supplementary, which means that they sum to 180. And then down here, we really need to remember this. I told you in Unit 1. Vertical angles are always congruent. Remember, verticals are those cross ones, the left, the right, the top, and the bottom. No matter how I change these angles, the top and the bottom will match each other, the left and the right will match, and then same if I do that. Linear pairs are also supplementary. You should remember that. So now we need to identify the pair as either congruent or supplementary, and then tell why. Well, 3 and 5, they are on the inside of the hamburger. So they are interior, and they are alternate. One's on the right, one's on the left. They're alternate interior. So if I go up and I look, it looks like alternate interior were congruent. And then the reason they're congruent is the angle relationship that we identified. The other one here, 1 and 8, okay. Well, let's identify what angle relationship 1 and 8 have. They're both on the outside of the hamburger, so they're exterior. I know that for sure. Now to figure out if they're same side or alternate. Looks like they're both on the left. So I'm gonna go consecutive in exterior, and up there, consecutive exterior tells me that they are supplementary. These will add up to be 180. And then blue looks like, one's on the outside, the other's on the inside. The only hope is corresponding. Top right. Okay. So I have corresponding. And my corresponding angles are congruent to each other. So you can take a look. You can look at these ones I've highlighted here. Look how we just worked with 2 and 6. Look at the type of angle 2 is. It's more than 90, right? It's obtuse. 6 is also obtuse. If you have parallel lines, you can identify this relationship simply based on what type of angles you have. This is obtuse, that's obtuse. If they're the same type of angle, then they're going to be the same. Look at the purple one that I had here, 1 and 8. 1 is acute, it's less than 90, it's tinier than 90. This one down here, 8 is obtuse. If you have an acute and you have an obtuse, they're not the same kind of angle, so they're not going to be the same. The only other option is for them to be supplementary. Now we're going to start filling in some actual values. So, yeah, lots happening here, but it tells me measure of angle 1 is 65. Find the rest of the measures and then explain why. So if I zoom real far in on this picture, it might be easier to see. I have angle 1, it tells me it's 65. Angle 1 is an acute angle, right? It's less than 90, which makes sense. 65 is less than 90. So I can go in and I can actually label all of my acute angles as 65. 1 is acute, 2 is obtuse, 3 is acute, 4 is obtuse. Okay, now down here, looks like 5 and 7 are my acute angles. Okay, so actually I did half of this problem already. 5 was 65, 7 was 65, and there should be one more. 3 was 65. But just saying that, well, one's acute, so the other ones are acute or equal, shouldn't that work? No, I need to now use my angle relationships, but you can build your own adventure here. There are lots of different ways you can say this. 1 and 3, what's their relationship? Well, ignore everything else, right? Ignore the bottom. Look at just 1 and 3. They're vertical to each other. We have directly across. So my reason will be vertical angles. Five, okay. 5 and 1, what's their angle relationship? Well, it looks like 1 is on the outside, 5 is on the inside, so they must be corresponding. Top left, top left. Yep, they are corresponding to each other. And then 7, how does 1 relate to 7? They're both on the outside of the hamburger. One is on the left, the other's on the right. So I have exterior because they're on the outside and they're on opposite sides. So alternate exterior. All right, now that solves all of my 65s, but I need to figure out 2, 4, 6, and 8. All right, well, if I zoom back in, it might be easiest to see that 1 and 2, they make a straight line together. If I cover everything else up, 1 and 2 fall flat on that line. And I know that straight lines are worth 180. Ooh. Nope. Okay. Well, if 1 and 2 together make 180, I can just take 180, take away the 65 that I have to figure out what should be left. So angle 2 is 115. And the reason I knew it was 115, what was 1's relationship to 2? It wasn't alternate exterior, it wasn't vertical, it wasn't any of that. It was that they formed a linear pair. So now let's go around and fill in the rest. 2 is obtuse, right? It's more than 90, so that means all of my obtuse angles are gonna be 115. So now let's build in these relationships. How does 4 relate to 2? Well, it's equal, right? They're both 115, but what's the name for their relationship? Just like 1 and 3 were vertical, 2 and 4 are also vertical. I said 6 was 115. How does 6 relate to 2? Well, they're corresponding. They're both in the top right position, one on the outside, one on the inside. So 6 is 115 because it is corresponding. To angle 2. And then 8 I said was 115. What was my reason? How did it relate to number 2? The same deal. They're on the outside, so I have exterior, and they're on opposite side, so alternate exterior. If you look at my reasons here, vertical, vertical, corresponding, corresponding, alt exterior, they're all the same because they flow, but this is totally an acceptable answer. But you could have jumped around and built your own. You could have said that 8 was worth 115 because it was a linear pair to 7. That would work. You could say that 5 was 65 because it was same side interior to 4, right? Those would be supplementary as well. So there's lots of different ways to prove your thought here. It just needs to be accurate. All right, here in example 6, it tells me that, example 3, that 6 is worth 142. You can do the same thing here. And you could fill in, okay, 6 is obtuse, so all of my obtuses are 142. And then you could figure out the other missing ones by going, okay, well, I know that there's 180 in a straight line. Take away the 142 and I should get, what, 38 for the rest of them? So all my acutes now are 38. And you can follow the exact same thought process as the top one to do this. This one's a little bit more involved, but not really. 5 is 82, okay. find the rest. 5 is 82. Okay. Well, it might be hard to see, maybe, but 5 is an acute angle. It's slightly less than 90. So all of my acutes here, 4 is acute, this is acute, and then up here, yeah, I just figured out a lot of those really fast. And then how do I figure out what I'm missing? Well, if 4 is 82 and 4 and 10 make a straight line, 180 take away 82, that's going to be 98. So that means the rest of my angles, my obtuse ones, are going to be 98. Okay, and the rest of it, you can fill that in. And it didn't say, I believe, to explain in this one. No, it just said find. We just figured out everything. It was either 82 or 98, whether or not it's acute or obtuse. This is relatively simple. Okay. Now this one might be a little bit more tricky. It says 12 is 121 and 6 is 75. So 12 is 121. And 6 was 75, right? Yeah. Find everything else. Okay. So this one looks a little bit more involved. It is. Start with vertical angles. It's always where I start. It's always the easiest. I know that 12 is 121. So what's vertical to 12? What is directly across on the x? Well, 7. And then what's vertical to 6? What's directly across from 6? It's 1. Okay, so I could fill in both of those right now. 1 is 75. And 7, it's over there, it's worth 121. Okay, so my vertical angles are done. I found those. After I check the verticals, I go for straight lines. 7 and 8 make a straight line, so 180. Take away 121, you get 59. So 8 is worth 59. But I also, if I figured out 8, I know what 11 is now because 8 is vertical to 11. So I figured out those two. 8 is 59. And so is 11. Okay. Now I figured out all of these. Good for me. Let's see. I can't do the straight line trick up here because 1 and 2 don't make a straight line. That's not a full straight line. 1, 2, and 3 all make a straight line, but I don't have enough information. So, okay. I think I'm at a stopping point. I don't know anymore based on vertical and based on linear pairs. I can't do any more work. So I need to use one of my angle relationships to figure out where to go from here. I need to find a corresponding or an alternate interior or something like that. But it's up to me what I choose. This arrow on this line here and that one there tells me that these two lines are parallel. So I can find a transversal, let's say this line here. And now I can use my corresponding or my alternate interior. For me personally, corresponding is easiest to see. I'm gonna pick on 11, because I already know what it's worth. 11 is worth 59, and in this, it's the bottom left. So up here, I'm gonna go bottom left to find corresponding. Do 11 and 4 look about the same? Yeah, they're both acute, and they're in the bottom left, okay. So that's gonna be 59. I found out 4. But I didn't just find out 4 because 3 is vertical to 4. So if I found out 4, I also found out 3. And now I can figure out probably the rest of this. Let's see. I know, because I just said, that 1, 2, and 3 all together make 180. Well, I know 2 of the pieces. I can take them away from 180 to find what I'm missing. Let's see, what is that? This is 105. 105 take away 59, I think is 46. I could be wrong, but I think it's 46. Good, I don't have that page. All right. Yeah, it's 46. But if I found out 2, I also know what 5 is worth because these are vertical. So 46 for 5. Okay, now all of this is done, all of this is done. I just need to figure out here and watch how easy this comes together. What we've made here accidentally with this shape is a triangle. Might be hard to see, but look at this right here in the middle. That's a triangle. And just like straight lines are worth 180, triangles are also worth 180. And I have 2 of these pieces. I have this piece and I have that piece. Let's do the same thing that we did over here to figure out what 9 is worth. 180, take away this 59, take away this 46. And that should be what we're missing. That's gonna be what? 75? Add that, you get 60. Yeah, 75. So this missing piece, this 9 here, 75. Now I know 9, vertical to 9 is 14. And the last piece of this puzzle, I know that 14 and 13 make a straight line. So 180, take away the 75, gives us our final answer of 105 for here. And then since 13 and 10 are vertical to each other, 105 for there. So yes, a lot happened. I'm not gonna say that it didn't, but we pieced this together. And what did we get? 14 answers? 12 answers because it gave us 2 of them relatively quickly. We can do this. Okay. We're gonna skip those ones and we're gonna pick back up here with our algebra.